All right, so this video is about special right triangles. So there are two types of special right triangles. There's a 30, 60, 90 and a 45, 45, 90 triangle. So when I talk about 30, 60, 90, I'm talking about the angles on the inside are 30, 60, and 90, and the angles on the inside are 45, 45, and 90. So that's how we refer to them. Now, they all follow a similar pattern in the sense that when you find these triangles, when you're doing problems, they may be scaled up or scaled down from what you see on here, but the ratios will remain the same. That means that the relationships between these sides will stay the same. It'll make more sense once we do a couple of problems, but first I'm going to describe a few issues that students have with this. So for the 30, 60, 90, it's very important to remember that the angles that are the smallest have the smallest sides across from them. So across from the 30, we have the smallest side of 1. Across from the 60, we have the larger side of root 3. And then, of course, our hypotenuse is the biggest side that we have, which is represented by a 2. Then for the 45, 45, 90, we have the legs are the exact same. They will always be the same as each other. And then the hypotenuse will be square root of 2. So when you're traversing between one side to another, ask yourself, how do I get from 1 to the square root of 2? And the answer is you multiply by the square root of 2. So we'll just do a couple problems, and hopefully it'll make a lot of sense. So this one is from your week 16 worksheet. Also, one thing real quick, if you haven't written these down already, please do so, because these will not be given to you for the test, but we expect you to memorize them. And the more that you write it down, the more you'll memorize it. So let's take a look at the week 16 worksheet. Number 1 looks like this. Has a 60-degree angle here. And it has 2 here, and it's asking us to solve these two sides. Now, I know that this angle here is 60 degrees, so I can figure out that all the angles in a triangle add up to 180. So 60 plus 90 is 150. 180 minus 50 is 30. This is clearly a 30, 60, 90 triangle. Now, let's go over to our reference triangle, 30, 60, 90, right? So across from the 30, we have the shortest side of 1. So what I like to do is I like to write in parentheses a little 1 here. Across from the 60, we have the side of root 3. Now, these aren't the actual values of the side, clearly, because this side says it has a value of 2. But for our reference triangle, it has a value of 1. And then the hypotenuse has a reference value of 2. So from here, we have to ask ourselves, well, how do we get from 1 to 2? The answer is we multiply by 2. 1 times 2 equals 2. So we're going to do the same thing. 2 times 2 equals 4. And that's how we find out the value of the hypotenuse. Now, the square root of 3 is a little bit more intuitive. We have to ask ourselves, how do we get from 1 to the square root of 3? I've seen that sometimes some teachers will put 1 in front of the square root of 3, just to make it clear that you're multiplying 1 times square root of 3 gives you 1 square root of 3. But in short, to get from 1 to the square root of 3, we multiply by the square root of 3. So we end up with 2 times the square root of 3 gives us 2 square root of 3. So those are our two answers for finding those two sides. Let's do number 7 from your homework. So number 7 looks like this. It's got 45 degrees right here, and because all the angles add up to 180, I know this angle also is 45 degrees. So we need to find the other two sides of this triangle. So let's take a look. For our 45, 45, 90, our legs have a value of 1, and our hypotenuse has a value of square root of 2. Or if you want, you could call it 1 square root 2. So the legs of a 45, 45, 90 are always the exact same. That makes sense because it's an isosceles triangle. The angles are the same and the legs are the same. So this side over here will be exactly the same as the leg over here, which is 7. Those should be exactly the same. How do you get from 1 to 1? You multiply by 1. It's the same thing. So that's easy enough. But how do we get from 1 to the square root of 2? Well, we multiply by the square root of 2. So we do the same thing, but this time we use the 7. 7 times square root of 2 gives us 7 root 2. So those are my two answers for those two sides. Let's see. Let's do a little bit more of a tricky one. This is also on the week 16 worksheet, but it's on 6.6a. It's on the second page. It's right here. Oops, right there. This one asks us to find the missing side lengths and then find the area in the perimeter. So for this one, we have a 45-degree angle, which means that this one's also 45 degrees. And then this measurement is square root of 2 meters. And we need to find these other two to find the area in the perimeter. So looking at my 45, 45, 90, I know that my legs should have a reference value of 1. So these will both have a reference value of 1. And then my hypotenuse will have a reference value of the square root of 2. Now listen, just because this side has a square root of 2 doesn't mean that this side represents it. In fact, it's quite the opposite, right? Because you can tell that this is the hypotenuse of this triangle, but the square root of 2 is on the leg, whereas the square root of 2 is on the hypotenuse for this one. So don't do it based on where you see square root of 2 or square root of 3 for that matter. That doesn't really tell you anything. You need to pay attention to where your angles are and what sides you're talking about. So for this one, this represents a value of 1, which means that obviously the legs are the same. So this side is also going to have a value of root 2 meters. And then how do we get from 1 to the square root of 2? Well, we multiply by the square root of 2. So this value right here will be the square root of 2, right, which is what we started with, times, to get from here to here, is the square root of 2. And that will give us our answer, but first we should simplify it. So square root of 2 times the square root of 2 is the square root of 4, and the square root of 4 is just 2. So my hypotenuse has a value of 2 meters. Now we need to find the area in the perimeter. So the area for a triangle is equal to 1/2 base times height. So in this case, 1/2 root 2 times root 2. And then we just simplify it, right? So root 4 over 2. And then the square root of 4 is 2 over 2, which is 1. That would be the answer. Now, of course, this isn't the final answer. Our answer should be 1. What are our units? Meters squared. 1 meter squared. Don't forget your units. And then finally, perimeter is just going to be us adding up all the sides around it. Like, picture it's a building and you have to walk around the building, right? That would be the distance. So it would be root 2 plus root 2 plus 2. Now, root 2 and root 2 are like terms. We can combine these. Treat it like an x. So we'd end up with 2 root 2, because there's 2 of them, right? And then plus 2. And then don't forget your units. In this case, it's meters. That would be my answer for the perimeter. Now let's do one more. I'm not going to solve the area and perimeter for you guys on this one, but this is 6.6b. So 6.6b says 60 degrees, which means that this one must be 30 degrees. And then it gives us 10. We have to find these other two sides. So if you remember, my hypotenuse should have a value of 2 for the reference. And then my short side across from the 30 should have a value of, across from the 30 should have a value of 1. And across from the 60 should have a value of root 3. So how do we get from 2 to 1? Well, the answer is we divide by 2, right? So we need to take our 10 and we need to divide it by 2. 10 divided by 2 is equal to 5. 5 should be the length of this side. Now, how do we get from 1 to root 3? Well, we multiply by root 3. So we need to do 5 times root 3, which would be 5 root 3. So that's how you find all 3 of those sides. Hopefully this clears a little bit of it up. I think that's about it. I think that's about as hard as it gets. Maybe, let me see. Maybe we can do one more. Here we go. This is going to be number 14 from your special right triangles one. This one's a little bit trickier. This is from the special right triangles worksheet. Sorry. And it looks like this. So it asks us, here it gives us 8, gives us 45 degrees, and then it asks us to find these two sides. Well, I know that my hypotenuse represents root 2, and I know that my legs represent 1. So how do I get from root 2 to 1? Well, the answer is I divide by root 2. Root 2 divided by root 2 gives us 1. So I need to divide by root 2 from 8. So my answer would be 8 divided by square root of 2. But this is not allowed. You cannot do this. You do not want a radical in your denominator. That's not allowed. So we need to do what's called rationalizing this. So to do that, we multiply by that same square root that we see right here, square root of 2, in the numerator and the denominator. What this does is essentially ask yourself, what is root 2 divided by root 2? That's just 1, right? If we multiply anything by 1, it stays the same. So really, we haven't changed what this number is. We just changed how it appears. So 8 times root 2, that gives me 8 root 2. So you just multiply straight across the top, 8 root 2, over root 2 times root 2 gives me root 4, which we've already determined root 4 is the same as 2. So we end up with 8 root 2 over 2. Then we can simplify this. 8 divided by 2 is 4. So we end up with 4 square root 2. And then, of course, the legs are the same. Right, so 4 root 2 for both of those. So hopefully this was helpful. Let me know if you guys have any questions in class. But other than that, that's about it.